This podcast has never had ads or sponsors, thanks to the incredible support from our Patreon community. If you want to support independent space journalism, go to patreon.com/universe today. Can the difficulty of interstellar travel answer the Fermi paradox? Or maybe it's the fact that we can only apply it to our galaxy and not further. Or maybe we can't even find life in our solar system. And in Q&A Plus, what if we discover an exact copy of the Earth with the ISS circling it? What are the odds? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Josh B., what is your favorite mind-blowing space fact? Man, I got like so many of these, but it's hard for me to like pull them up randomly. I have to sort of pull them up in context. It's tough. That a grain of sand hitting a spacecraft going at 20% the speed of light would be the equivalent of a bomb going off on the spacecraft. That cosmic rays, as they go through your body and cause damage to your DNA, the damage they're doing is that they're stripping away the electrons from your atoms of your DNA. Yeah, there's too many of them. Spaceman legend. If you had to put money on life being found on Europa or Enceladus, which would you pick? Also, is there actual video of planets orbiting other stars? So which would I pick? I mean, they're all interchangeable. So with Europa, Enceladus, Titan, Pluto, Ceres, any icy world, you've got this thick shell of ice, and then you've got a ocean of liquid water underneath that is kept warm by some kind of hydrothermal activity. So you've got all the raw ingredients. You've got the raw ingredients for life. You've got the minerals and stuff that are being put into the water. The water is going to be liquid water. And so it's kind of the same environment across all of them. And then the question is, did life form independently on each one of those worlds? That would be cool. That would be weird and crazy and cool. Or did life get around from world to world? And so then the question is, what is the place where an asteroid carrying life from Earth or Mars crash into Europa or Enceladus and be able to deliver the goods? And really, it's about getting through the ice shell. With Europa, I mean, that shell could be 100 kilometers thick, 80 kilometers thick. Like, we just don't know how thick the shell of ice is on Europa. But there could be ways that material is being transported up and down through the ice on Europa. There could be cracks in the ice where water is welling up and then the water is going back down. And so even if a meteorite just lands on the surface of Europa, maybe it could sink in and then the life could find its way down into the interior and then life could spread. So I don't really have a preference for which one is more likely to have the life, but the one that is easiest to check is Enceladus. And that's because it has the geysers. It is actively throwing this water out into space. And so if you want the answer to that question, you just go and fly through the plumes at Enceladus and taste the ice and find out if there's any life or the chemicals of life and so on embedded into that. So, it doesn't really matter, but we just go with the low-hanging fruit. Look at the places where it's easiest to explore. And then there are videos of planets orbiting other stars. There are some really cool time lapse. So do a Google search for HR 8799 and you will see a really cool video of exoplanets orbiting around a star. Real video. Todd Gibson Art, do you think the difficulty of interstellar travel is the answer to the Fermi paradox? Find it incredibly difficult to imagine interstellar travel based on travel times alone, much less grains of sand. I mean, Oumuamua came to the solar system from another star system and it made the journey. So if like dumb rocks can make the journey, why can't smart rocks make the journey? Like, add some robotics to Oumuamua. Give it the ability to steer, a little bit of propulsion, a way to consume the interstellar asteroid to chart a different course or go faster. So no, I don't think that interstellar travel is a showstopper for why we don't see aliens. It's time to shout out all the new $5 patrons and above. G-Bots, Joseph Donahue, Mark Parkinson, Nut Watchtig, Mark Y28, Adriano Tranahi, R. Singh, Alex B., Glenn Samuel, and RM. Join the club at patreon.com/universe today. G. Mole. Given that the Fermi paradox was strictly limited to possible alien civilizations in the Milky Way galaxy, why do so many misrepresent it as applying to the entire universe? Are we alone? I don't think that the Fermi paradox was strictly applied to the Milky Way galaxy. It was just that was the thought experiment that Fermi did to then ask, where is everybody? That if the universe is big and it's old and life formed early on planet Earth, then life should have formed across the galaxy on many different planets. And then people would be going from planet to planet in the way that people go from city to city here on Earth. And so where is everybody? But, we have ways of observing other galaxies and seeing potential civilizations that are going to have a large impact on their home galaxies. And so I think that it beautifully applies to a larger thing. And so the one of these concepts in astronomy is that you say that we don't live in a special part of the universe. That what we see around us, planets, moons, stars, gas, dust, nebulae, pulsars, all of the stuff that if you go to some random place in the universe, some random galaxy in the universe, you're not going to see the exact same things, but you're going to see roughly the same thing. And so if we see here in the Milky Way no life anywhere, then that is a representation of what you should expect to see in all of the galaxies, no life anywhere. But if we saw life teeming here in the galaxy, then you would expect to see that teeming in other galaxies as well. So I think it's a perfectly reasonable extension of, if we don't see anybody here in the Milky Way, why don't we see anybody out there in the universe as well? DB Ireland. Smart man, have you ever thought that life on this planet was seeded by another interstellar species? I say that considering the improbability of all life development from single cells. Yeah, this is one perfectly reasonable explanation for the existence of life on Earth, that life formed as soon as it possibly could on Earth. The second planet Earth had cooled down to the point that life wasn't caught on fire by molten magma, then it formed. And that's weird, right? That if you would expect that life would have taken a while to get its bearing, take its time, but no, it's like non-life to life. And obviously one possibility is that that's just how it worked out. But it's not what you would expect, right? If you were sort of expecting probabilities, if there's the entire age of the Earth's history, then you would expect life to have formed at some random point along that process.